Alright, so thanks guys for bearing with me while I'm off for a couple of weeks. This will be the last week. I should be back next week. Um, so yeah. Anyways, we're gonna I thought I'd share. Here is my baby girl. So these are my two girls. The one on the right is my first, and the one on my left is my new baby. Welcome, baby P number 2. I have another baby girl. So if I seem cranky or tired, it's because these two are keeping me up. She here on the right is 2 years older than my baby on the left. Anyways, back to the fun stuff. Math. We are in Say It With Symbols. Say It With Symbols. We're going to do 1.2, 1.2, 1.4 today. It might take a little bit longer than one video. Just keep that in mind. It might be a little longer. So you have class time to work on it. Say It With Symbols is our second to last unit, and I think we'll be done soon. We fly through this unit pretty quickly. I'm going to give you a quick breakdown of the schedule, and you can see what's coming up. So here's our schedule. Today's the 25th. I'm recording. Monday the 27th, when you're in class, you'll do 1, 1, 1, 2, 1, 4, 2, 2, 3, the partner quiz on Friday this week. Next week we'll go through all of 3. We only hit 2 sections in there. We do only 2 sections in Investigation 4. We only do 3 sections in Investigation 5, and then we'll be done. So it's only going to take us about 3 weeks to get through this whole unit, because the week in between, that's spring break right here. So yeah, this unit's going to go fast. It's a lot of algebra-based stuff, and a lot of you guys are pretty good with that. Alrighty, so let's get to it. Writing equivalent expressions, March 27th, Monday. I don't know what page number we're on. I seem to be losing track of days pretty quickly, not getting much sleep. Your focus question is, what expressions represent the number of border tiles needed to surround a square pool with side length S? So we're coming up with expressions that are going to go around a pool that represent how many tiles we have around this pool. So in this case, this is a tile, that's another tile, that's another tile, a tile, a tile, etc. These are all tiles, border tiles. Okay, so we need to come up with an expression based on the side lengths. So if we don't know how long the side lengths are, in this case we know they're 4. 1, 2, 3. Well, sorry, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's 12 plus 4 more gives me 16. Well, how do I come up with 16 if each side length is only 3 units long? Okay, so that's what we're working on today. Okay, so this is on page 9 in your textbook, and I'll post the textbook online for you guys as well. If you'd like to, you're more than welcome just to pause the video and use the same questions. I retyped them. It took me longer than I needed to. I don't know why I did it. So next time, for the other pictures, I didn't retype them. It says, write an expression for the number of border tiles needed to surround a square pool with the side lengths S feet. So that's this one over here. Not particularly this one. They're just showing you an image of it. So I need to come up with an expression to represent this one. Now keep in mind that an expression is different than an equation. So this section right here where it says expression, okay, later on it asks you for an equation. So for now, our expression should have no equal signs, okay, no equal signs, okay. So I'm going to write an expression here that's going to represent this equation. If you want to give it a try on your own, pause the video now and try to write an equation and see if you come up with something similar to what I come up with. Yours might be different, and that's okay. So this is the equation I'm coming up with. I know that the tiles here, so from this length to this length, is going to be S. I know that's going to be the same from here to here. Okay, that's S. This is S from here to here. That's also S. And from here to here, that's also S. Now the parts it doesn't account for is 1, 2, 3, 4 tiles. There's always an extra 4 tiles because for each corner, those are not up against the sides. So my equation is going to be S plus S plus S plus S plus 4. Why? There's 4 extra tiles each time around. Okay, there's 1, 2, 3, 4. In this one, there was 1, 2, 3, 4. Every single time, there's 4 tiles that aren't included in the side lengths. Now, I don't have an equal sign here, and it's because it's asking for an expression. Now, it says write a different but equivalent expression for the number of tiles needed to surround the square pool. So what it's asking you to do is write something exactly the same in a different way. Okay, so I'm going to write this in a slightly different way, and I'll show you which items I'm combining. So I'm going to have this side here, right there. I'm going to call that S plus 1. S plus 1. So I'm going to say that's going to be S plus 1. Okay, and I'm going to do that 4 times, not 5 times. There's 1 there. There's 1 section. I should be doing this in green. And there's another section here. That's 2. Here's another section here. 3. And then 4. So I'm going to call this S plus 1. And then I'm just going to do that 4 times. 1 for each side length. S plus 1, S plus 1, and S plus 1. I should have plus signs in between each section. Okay, so plus this one, plus this one, plus this one. Ta-da! Okay, these two are exactly the same. I just wrote it in a different way. That's all it's asking. Describe how you can prove that the two expressions are equivalent. Okay, so I'm gonna, you know what, this one here, you can do that one on your own. A3, you can do on your own, and I'll work on B1. Again, if you want to work on this on your own without my help, because these are the ones I thought would be a little confusing. So I'm going to write an equation now, and it tells you write an equation for the number of bordered tiles in question A, then fill out tables and graph it. Okay, so it says I'm going to write an equation, and I'm going to have it equal to something. Okay, so I'm going to pick the same equations here. So this one I'm going to put down here. Okay, and I'm going to make an equation for each one of these, and I'm going to see that they're equal to each other. I'm going to graph it too. Okay, so I'm going to make this equal to the number of tiles. So this is going to be equal to n. N equals number of tiles. Now it's an equation. That's the difference. Once it didn't have any x equal sign, now it does. It says write an equation, done, and it says make a table for the values of each side. Alright, so I'm going to make a table of values. I'm going to put the side length here and the number of tiles. Okay, so if the side length is 1, side length is 2, 3, 4, and then 5. And then I'm going to again repeat this for this equation and see if I get anything different. I should be able to get the same thing. That's what equivalent expressions mean. Okay, so if S was 1, and I filled this out, 1 plus 1 plus 1 plus 1 plus 4 is 8. If this was 2, 2, 4, 6, 8, 12. This was 3, 3, 6, 9, 12 plus 4, 16. If this was 4, 4, 8, 12, 16 plus 4 is 20. If it was 5, 10, 15, 20 plus 4, 24. And if we do the same thing here, 1, 2, 3, 4 plus 4 ones is going to be 8. And if you do all the math, they end up being the same thing all the way through. Good? All right. So Is this relationship linear? Well, let's check. The linear is a repeating addition pattern. So from one to the next, what happens? What's happening? Well, that's plus 4, plus 4, plus 4, plus 4. And is there a pattern here as well? Plus 1, plus 1, plus 1, etc. Plus 1. And since they're the same, yes. Yes, because the patterns are constant rates of change. Every time the side length increases by 1, the number of tiles increase by 4. There you go. All right, pretty easy. Okay, 1.2, determine equivalence. Again, your focus question and your title. Do a quick drawing, just a real quick sketch. This is using tiles, and these are algebra tiles. These are using tiles to write out each statement. So S is going to be represented by this, and these 1 squares, a 1 by 1, is going to be represented by these greens. So let's label those. This is an S, this is an S, this is an S, S, and this is a 1, 1, 1, and 1. It says 4 students in Takashi's class came up with different equations for counting the number of border tiles. For each equation, make a sketch that shows how the students might have been thinking about the border tiles of the pool. Okay, well, what it's telling you is this is the equation. We have to rearrange these items to fit this equation. So I'm going to do the first one for you, and I'm going to let you guys figure out the other ones. Okay, so this first one, I'm going to make, it says S plus 1. So I'm going to do that part first. This is my parentheses. So S plus 1, fill this. Cool. All right, here's my S. Okay, here's my drawing. It's beautiful. Okay, and then here's my plus 1. I think it's this color-ish. Pretty close. S plus 1. Oops. Totally did not want that. I wanted it to be filled that way. Cool. All right. So there's my S plus 1, and then I'm going to multiply it by 4. So that one is my S plus 1, and it says times 4. Okay. Now this times 4 part, well, I don't know if that really counts. That's kind of like doing the math in there. So what I'm going to do is I'm going to make 4 groups of that. Okay, so there's one group. I'm going to make this group a little bit smaller so I don't have very much space. There's another group. There's another group. And there's another group. I think this is a better representation of S plus 1 times 4 because there's 4 of these being added together. Right? 4 of S plus 1s together. Okay, how would you represent this with symbols? How would you represent this with symbols? And how would you represent this? This is pretty tricky. Okay, for equation B, use each equation in question A to find the number of border titles needed for side length 10. So what you're doing here is in each one of these equations, number 1 for Stella, you're going to write the equation n equals 4s plus 1, but s is 10. So let me do that first one for you. I'll do it down here. I'll call this B1. B1, the equation is n equals 4s plus 1, and s for all of them will equal 10. So I'll have number of tiles is equal to 4 times 10 plus 1, n equals to 4 times 11, n equals to 44. And then you're going to do that for this one, for Hank's equation, Sal, and Jerry's. Okay, I'm going to continue the video on the second video.